Hello, dear friends. I am your royal narrator, Queen Magical Melanin, extending a warm greeting to all gathered for our basic applied electronics information session produced by the esteemed Baba Jalani Bomani Dembe, the brilliant mind behind Majestic Mind Matters University, and the mandatory Mental Liberation series, eagerly enriching our learning journey. Today, we venture into the world of basic applied electronics, where circuits and currents intertwine to unlock endless possibilities. Let us embark on this enlightening adventure together, exploring the wonders of technology and innovation under the guidance of our distinguished instructor Baba Jalani Bomani Dembe. Welcome to a transformative experience that will ignite your curiosity and mastery in the field of applied electronics. So pay close attention and take plenty of notes to prepare you for possibly answering a few easy questions near the end of the session. In this basic applied electronic information session, you will be introduced to the fuse. A fuse is a crucial component in electrical circuits that serves as a protective device to prevent excessive current flow that could potentially cause damage or even lead to a fire. By simply incorporating a thin wire or element that melts when current exceeds a specified level, fuses are designed to break the circuit and interrupt the flow of electricity. This sacrificial act essentially makes the fuse the weakest link in the circuit, sacrificing itself in order to protect more valuable components or prevent potential electrical hazards. In order to ensure the effectiveness of a fuse, it is important to understand its principle of operation. When the current passing through a fuse surpasses its rated capacity, the heat generated causes the thin wire or element inside the fuse to melt, thereby breaking the circuit. This disruption halts the flow of electricity and prevents further damage to the circuit components. The selection of an appropriate fuse is crucial, as using a fuse with a higher rating than necessary could fail to provide adequate protection, while using a fuse with a lower rating could lead to unwanted interruptions in the circuit. Fuses are commonly classified based on their current carrying capacity and voltage rating. Cartridge fuses, for instance, are cylindrical in shape and typically used in industrial applications where higher currents are involved. Blade fuses, on the other hand, are flat and rectangular in shape and are commonly used in automotive and electronic applications. Resettable fuses, such as circuit breakers, are able to automatically restore the circuit once the fault is cleared, thereby eliminating the need for replacement. One of the primary functions of fuses is to provide overcurrent protection. Overcurrent occurs when the current flowing through a circuit exceeds the specified limit, which can result from short circuits, ground faults, or simply an overload of devices connected to the circuit. Without the presence of a fuse, the excessive current could lead to overheating, component damage, or even start a fire. By breaking the circuit in response to overcurrent, a fuse acts as a safety mechanism that prevents such catastrophic events from occurring. In addition to protecting against overcurrent, fuses also play a critical role in preventing equipment damage. By limiting the amount of current passing through a circuit, fuses help protect sensitive electronic components from potential damage. This is particularly important in circuits where expensive equipment is involved, as even a small surge in current could lead to significant financial losses. By sacrificing itself under critical conditions, a fuse acts as a cost-effective solution that safeguards valuable equipment from harm. Furthermore, fuses are essential in preventing electrical fires. The potential for fire is always present in electrical circuits, especially when there is an overload of current that can generate excessive heat. By interrupting the flow of electricity when the current exceeds the specified level, a fuse effectively reduces the risk of overheating and minimizes the chances of a fire starting. This proactive measure not only protects the circuit components, but also ensures the safety of individuals in the vicinity by preventing any potential fire hazards. Fuses are integral components in electrical systems that provide crucial overcurrent protection, prevent equipment damage, and minimize the risk of electrical fires. By sacrificing themselves to protect more valuable components, fuses serve as a vital safety mechanism that ensures the smooth and reliable operation of electrical circuits. With a wide range of options available to suit different applications, fuses continue to play a key role in maintaining safety and efficiency in electrical systems. Fuses are crucial components in electrical circuits, designed to act as weak points that will break when subjected to excessive current flow. The purpose of a fuse is to protect the other components in the circuit by sacrificing itself in order to prevent damage. By interrupting the circuit when necessary, fuses play a vital role in ensuring the safety and functionality of electrical systems. The basic concept behind a fuse is simple but effective. A fuse is typically made of a material such as a thin wire or strip of metal that has a lower melting point than the rest of the circuit components. When current flows through the fuse, it encounters resistance, which causes the fuse to heat up. If the current exceeds the rated amperage of the fuse, the material will continue to heat up until it eventually melts or blows, breaking the circuit. This action stops the flow of current and prevents damage to the rest of the circuit. The key to the effectiveness of a fuse lies in its ability to accurately and reliably react to overcurrent conditions. Fuses are rated based on their amperage, which is the maximum amount of current that they can safely handle. When selecting a fuse for a specific application, it is important to choose one with a rating that corresponds to the expected current flow in the circuit. If the current exceeds the rated amperage of the fuse, it will blow, interrupting the circuit and preventing damage. In addition to their material composition and amperage rating, fuses are also designed with a protective casing to contain any debris or sparks that may result from the fuse blowing. This casing is typically made of ceramic or glass to provide insulation and prevent any potential hazards. By housing the fuse in a protective casing, the risk of fire or other safety hazards is minimized, ensuring that the fuse can safely perform its function of interrupting the circuit when necessary. The role of fuses in electrical circuits cannot be overstated. Without fuses, electrical systems would be at risk of damage from overcurrent conditions, leading to costly repairs and potential safety hazards. By providing a designated weak point in the circuit, fuses offer a simple yet effective way to protect electrical components and ensure the safe operation of electrical systems. Fuses are commonly used in a wide range of applications, from household appliances to industrial machinery. In residential settings, fuses are often found in electrical panels to protect circuits from overloads. In automotive applications, fuses are used to safeguard critical systems such as the engine control unit and power distribution modules. In industrial environments, fuses are essential for protecting sensitive equipment and preventing downtime due to electrical faults. Fuses are essential components in electrical circuits that are designed to be weak points so that they will break when subjected to excessive current flow. By interrupting the circuit and preventing damage to the rest of the components, fuses play a critical role in ensuring the safety and functionality of electrical systems. With their simple yet effective design, fuses offer a reliable way to protect electrical circuits from overcurrent conditions and ensure the safe operation of electrical systems. In the world of electrical systems and circuits, fuses play a crucial role in protecting against overcurrent and preventing damage to the system. A fuse is a small, disposable device that is designed to break the circuit when a predetermined level of current is exceeded. This action helps to prevent overheating and potential fires in the system. However, for a fuse to effectively serve its purpose, it is important for it to be housed in a protective casing. The protective casing serves several important functions that are integral to the safety, durability, and overall functionality of the fuse. First and foremost, the protective casing of a fuse serves as a safety feature. In the event that a fuse blows or fails, it may release heat, sparks, or smoke. Without a protective casing, these hazards could potentially come into contact with flammable materials or other components within the electrical system, leading to a fire or further damage. By housing the fuse in a protective casing, these hazards can be contained within the casing, preventing them from causing any harm or danger. This is particularly important in industrial or commercial settings where the risk of fire or electrical accidents is higher. Additionally, the protective casing of a fuse helps to ensure the durability and longevity of the device. Electrical systems are often exposed to a variety of environmental factors, such as moisture, dust, and mechanical stress. Without a protective casing, a fuse is susceptible to physical damage, which can compromise its functionality and effectiveness. The casing acts as a barrier, shielding the fuse from external elements that could potentially cause it to fail or become faulty. This ensures that the fuse continues to operate properly and provides the necessary protection to the electrical system. Moreover, the protective casing of a fuse serves an important role in identification. Fuses come in various sizes, shapes, and ratings, depending on their intended use and application. The casing typically includes markings or labels that indicate the rating and specifications of the fuse. This information is crucial for users when it comes to identifying and replacing a blown fuse with the correct type. Without the protective casing, it would be difficult for users to distinguish one type of fuse from another, which could lead to incorrect replacements and potential hazards in the electrical system. Furthermore, the protective casing ensures that the fuse is compatible with the electrical system in which it is installed. Different systems may require fuses of varying sizes and configurations. The casing provides a standardized form factor for the fuse, making it easier to fit securely within the system and ensuring that it can be safely installed and removed without causing any disruptions or hazards. This compatibility is essential for the proper functioning of the electrical system and for maintaining its safety and integrity. In conclusion, it is clear that housing a fuse in a protective casing is essential for a variety of reasons. The casing helps to ensure the safety of the electrical system by containing any hazards that may be produced by a blown fuse. It also protects the fuse from physical damage, ensures its durability, and facilitates identification and compatibility with the system. Overall, the protective casing plays a vital role in safeguarding the fuse and maintaining the functionality and longevity of the electrical system in which it is installed. Thanks for your participation in this Majestic Mind Matters University Basic Applied Electronics Information session titled Introduction to the Fuse, Ashe.